So I think the pragma solidity version is not right. So usually we go with 0.8.18, which is the recommended version, but here they are using 0.7.6. I don't know why, because there are few vulnerabilities in this version, like underflow, overflow. Safe math function should be used while using 0.7. I don't know why they are using it. And we have few input statements here: C721 vulnerable address base 64. I think this is used for encoding purpose, like to deploy the metadata on chain, right? So we have few docs. The name of the, I mean, the title of the contract is puppy raffle, and call the enter raffle functions with the following parameters. So which takes an address of participant, a list of address that enters. You can use this to enter yourself multiple times, or yourself, a group of friends. Alright, so duplicate address or not allowed. There is a vulnerability here. Wait for it. Let me explain it. Users are allowed to get and refund. Okay, and every X seconds the raffle will be able to draw a winner and be minted a random puppy. Okay, that's good. Contract puppy raffle, it inherits from ERC 721 as well as the vulnerable. Okay, the stream is on. So we're using the address for address type. We have an entrance fee, which is a public variables. We have players, raffle duration, raffle start time, previous winner, and they're using like storage packaging for gas optimization. We have the fee address and the total fee. To keep track of all the uh, NFTs, they're using mapping. So this was very interesting for me, because we have three mappings: token ID to rarity, rarity to URI, rarity to name. So we have the name, rarity, as well as the token URI. You have three NFTs. Here you can see the most common 70, rare 25, legendary 5. It was nice. A few events should be emitted after a function is being done. Okay, so first thing is the constructor takes three parameters: entrance fee, the cost in where to enter a raffle. Okay, this is set by the owner while deploying the contract, because it is inside the constructor, as we all know. And we have the fee address, the address to send to. This is like once the raffle is been completed, the profit is being sent to this address. So this is also determined by the owner. Then we have the raffle duration, and the raffle start is nothing but the block talk timestamp, the current now when the contract has been deployed. Give me a second, guys. Alright, guys, so we are setting the mapping rarity to URI. So the rarity is nothing but the three variables: Rarity, common rarity, legendary rarity is set to all the IPFS links, URI. Alright, and rarity to name. So same thing, which is pointing to URI. Here it is pointing to the name. Here you can see the common, rare, and legendary. That is pretty decent. I could not find anything right over here. Here you can see the NFT name as well as the symbol. That's nice. I enter raffle. Here you have to pass an array of players. I think I will add an audit tag right over here. Alright. Yeah, enter raffle. So we are having an required function message.value should be equal to entrance fee of the length of the array. So for example, if the entrance fee is 10 and I'm passing 10 addresses, so 10 into 10 which gives the 100, so I have to pass 100 ether, just for example 100 ether inside this function, as it is a payable which could accept Ethereum. And I would recommend using if else, if error statements, because which is more gas efficient when compared to required statements. And we are passing iterating through this new players array. We are pushing into this players, so the players is the storage variable which we have declared right over here. Here you can see it's a public storage variable. And so it checks for the duplicates. So here comes another vulnerability, which is DOS. DOS stands for denial of service. As it is too gas intensive process, it ends up with the denial of service. So this is a vulnerability which I got through. And once the enter raffle function is been done, it emits the event with this new players array. It's pretty good. Yeah. Next we have the refund. As we saw, users are allowed to get refund for their tickets if they call the refund function, right? So that's the refund function over here. It takes an player index. Here this line is very gas efficient because you're not rapidly reading the storage variable from this players array. Rather we just passing this storage variable into the memory of this function, so which is bit gas efficient. We're checking for whether, so previously this line was down right over here. Alright, I just swapped it because it makes sense, right? So if it is not 0, then we can check whether the player's address is message.sender or not, right? So that's what I did. I think it makes sense. Yeah, let's save this one. And here, instead of send value, I think the most preferred is call. So let me give an audit tag. So we can use the call. So this is what the call looks like: the payable message.sender.call value entrance fee and the semicolon. Yeah, we are making the player's index to 0 address and emitting the event. That's it. That's pretty decent function. And we have get active index. What is the functionality? A way to get the index in the array. Okay, the player this one, the address of the player in the raffle. It returns the index of the player in the array. If not, it returns 0. Okay, we have to pass the address and it checks whether this address is present in this player array. If so, it passes, it returns the index, or else it returns the 0. I think that's good. I could not find any vulnerability there. And select winner. So this is very crucial function. Let's go through it. So it checks for few requirements. Let's see what is it. Block.timestamp should be greater than the raffle time start plus duration. Yeah, it checks for the raffle duration. That's good. Players, it should contain, the array should contain at least 4. That's the minimum criteria. That's good. This is definitely bad. ABI.encode packed, message.sender, block.timestamp, block. See, it's impossible to generate a random number, especially in a deterministic environment like block generate. I think they have to use some like chain link VRF instead of using this kind of, can be manipulated. Randomness can be manipulated. Randomness can be manipulated. So that's an error. That's a problem. And we are setting the winner to be the player. Again, we are reading from the state. That's good. What we are doing it right here. So total amount collector. Okay, we are calculating the entrance price pool. Okay, among it, 80% is set to the price pool, and then 20% is to the fee. Okay, the fee is added to the total fee. And what is this? Token ID, total supply. Okay, we're getting the token ID from the total supply function. Where is it? Okay, I think we are inheriting from something. I don't know which function. Honorable. Yeah. Inside 721 we have total supply. Right, that's good. It's good. Again, for rarity, they're using the same mistake. Audit. There's some alternative chain link VRF to generate random numbers in blockchain. Why going for this kind of things? It can be manipulated, blocked of difficulty can be manipulated by the miner, as well as message.sender can be manipulated by the participant. Okay, if the rarability is less than the common rarability, which means that common rarity 70, if it is less than 70, then they are assigning the token ID to common URI. Alright, so if it is rarity is less than okay, then we're going to go to the rare, else we're going to legendary. We're going to delete the players array. Alright, starting time, block.timestamp, we are restarting it. Previous winner is going to be winner, and this 80% goes to the winner by calling the call function, and we're checking whether success, and we're going to mint it. That's good. But the thing is, like, the randomness being generated here is definitely manipulatable. So you have to use some alternative like chain link VRF to generate verifiable randomness VRF. That's wrong. VRF in blockchain. Next we have withdraw. Address of the balance should be equal. I think it should be greater than or equal to. Maybe I audited this. and we are setting into the fees to the withdraw, and this is passed through the fee address. We can change the fee address only the owner, as we are inheriting from the ownable. That's pretty good. Is active player. Instead of the player, we are going to pass the message dot sender. If yes, true. If not, false. I could not find anything from it. So this thing is for token URI. Alright. So we're using the base URI, base 64 functionality, token URI. Yeah. So we're generating the token URI. We're seeing whether the token ID is already exist. If not, we are calculating the rarity from the token ID. From the rarity, we are getting the image URI, as it's a mapping. From again rarity, we are getting the number. We are first using abi.encode packed to pack all the metadata and converting it to the bytes using the base64.encode function. Then again we are going to encode with the base URI, which is this one, so that it can be rendered in the browser. Yeah, and again we're going to convert it into a string. That's definitely a good idea. The thing is, like, there are a few things, but apart from this, everything is fine. Looks good. I think I'm done with it. I have to go take rest few minutes before starting again. So thank you for watching. See you on the next live stream. Until then, this is Balamurugan. See you again. Bye bye.